This is literally the contest to give the pregnant girls because there's another one. That's why they make them so big. Eggs. Who? You don't even fit in this desk. You're like a stick in
Okay.
this. What? Which one? 3-1. 3-. This one.
3-1. Could I have everyone's attention, please?
You have long fingernails. What? Ew. Oh.
Okay. We're going to discuss today parallel lines and transversals. Now, parallel lines, we're going to write some... Is Mr. Rhodes speaking? Jonathan Sparks at Mr. Andrews' office? Very good. Mr. Sparza, Mr. Andrews' office.
It sounds like you hate him. You're like, I hate you.
You're interrupting my class.
Me?
They are.
Oh, okay.
All right. Topic 3-1, parallel lines and transversals. Let's write some definitions here. Parallel lines are lines with the same slope and they do not intersect. So a diagram of it would be like this. Okay? In other words, two lines with the same slope, they're never going to intersect, they're never going to cross paths. Perpendicular. So think, for example, Sycamore Street and Marvin Street. Those two streets run parallel to each other. They're never, ever going to cross. Right? Everyone know those two streets right here in town? No? Okay. Okay. Well. Okay. They don't cross. They're just straight up and down like this, same slope, forever and forever. You could track them for 1,000,000 miles away, and they would still not be crossing. Okay. Skew lines are lines with different slopes that do intersect. Okay? Very simply, if two lines are skewed, that means they are going to intersect. So for example, compared to each other, 77 out here and Indian Drive would technically be skewed. Why? Because they intersect. Northgate and 77. Okay, right to the north side of school. Northgate and 77. They're skewed because why? They intersect. But Northgate and Indian Drive, so the one right up front of HEB and the one right out front of the north side of school by Walmart, those two are parallel, they're not going to intersect. Okay? And then two planes, or parallel planes, are two planes that don't intersect. Okay? So, I'm going to leave that diagram in because it's very hard to draw that, but I'll show it to you in the next example that we do. Okay? Taking a look at example 1. Okay? All right, looking at this figure, it says use the figure below to answer the questions that follow. Okay? See if I can get that to focus anymore. There, that's better, isn't it? Yeah. All right, so using this figure below, answer the questions that follow. Okay? First of all, looking at this, what lines are parallel to line AB?
EF and DC.
So E to F, this line in here, so E, F, and DC. Okay, and that makes perfect sense. Why? Because they're not going to cross. I could take this thing forever and forever and forever and forever and forever and forever and forever, and they're never going to cross paths. Okay?
How?
Give me some example of some other parallel lines. DA and CB. What else?
EA and FB.
EA and FB.
AB and EA.
AB and what? Okay, we've already talked about that one.
ED and
But you're right.
FC.
What?
ED and FC.
Excellent.
What is that thing that you did?
Where?
That third one. DACB and what?
EA and CB.
EA. You put the E backwards there.
Where? Here? This is an E.
That's the way
It's
that.
like a 3.
It's another way to do an E.
That's like a cursive E, basically. Okay? So name a pair of skew lines. So give me two lines that are crossing.
ED and EF. Right? Yeah.
ED and EF, correct.
Okay.
Okay? Now if we want a little more tricky, but not too hard, give me a pair of parallel planes.
DCBA.
Okay, so,
Oh wait, no.
no, that wouldn't be parallel. There's one pair of planes that are parallel. Miss Day.
EA and CFB.
Yeah.
CFB, so EDA and CFB. Perfect. So you see these two right here are parallel. Why? Because they're on equal sides. So these two are parallel. They're right next to each other. They're never going to cross paths. They're never going to intersect. We're never going to have to worry about that. They keep going on and on and on and on.
By on, you mean like it gets bigger? Or like,
As in, the further towards infinity you go, so for example, if I were to have two planes and I were to stretch them out and make them bigger and bigger and bigger,
okay.
then that means that they would still never cross paths.
It'd be like 3.
If it's parallel, it cannot cross paths. Okay? So now we're going to discuss the concept of a transversal. A transversal is a line that intersects two other lines to form eight angles. Okay? So the principle of this is that when I have a transversal, I have a line, it's intersecting two other lines. So take a look at this example down here. I can draw it here for you, but okay? I have a line, I have two other lines that are being crossed by one line, okay? And as a result of that one line, 8 different angles are formed, okay? Okay? I'm going to put these definitions down for you to copy. A lot of definitions in this one. Okay, so I'm going to read them out loud to you. Alternate interior angles are angles between the lines, non-adjacent, and opposite sides of the transversal. Okay, so they're angles that are between the two lines. So if I were to look at, for example, this one right here. So here's my transversal, and then I have two lines. They're on the inside. It's fine. They're on the inside of my lines. Okay, and they're alternate because they're on either side of the transversal. Okay. So the first thing I look for is where they at with respect to the two lines. Okay?
And what does it say? What's the last one?
This transversal. Okay, so for example, angle 2 and angle 7, they're on opposite sides of it, but they're still on the same side of the lines, and 3 and 6 as well. Okay? Next one is alternate exterior angles. Angles outside of the lines, non-adjacent, opposite sides of the transversal. So, for example, let me fold this so we can see it. Okay, so like in this one, they're angles outside of the line, so they're going to be up here and down here. Okay? Like angle 1 and 8, they're alternate because they're alternating sides of the transversal, but they're exterior of the lines.
5 and what?
Okay, so like 5 and 4, this one right here and this one right here are going to be my alternate exterior. So once again, alternate because they're not on the same side of this transversal. Exterior because they're on the outside of the lines, and because of the fact they're on other sides in that, we see we have alternate exterior angles, such as angle 1 and 8, angle 5, and angle 4. Okay? The next one, you're going to need to draw a line in the middle of this box because it didn't get printed properly. I apologize. And I didn't realize it until after I printed them. Okay? Same side interior are interior angles on the same side of the transversal. Okay? So, they're interior, so they're inside the two lines, and they're on the same side of this transversal, the line that transverses and intersects both lines. So, for example, 2 and 3, they're on the inside, and they're on the same side. Inside and same side, inside and same side. Trying to make a jingle here, it's not working, but okay. Okay? So, for example, 2 and 3 and 6 and 7. They're on the same side and they're interior. Then, same side exterior, they're on the same side of this big transversal, but they're on the outside of the two lines. So exterior angles on the same side of transversals. Okay? So for example, 1 and 4. So 1 and 4, if you look right here, 1 and 4, 1 and 4 are going to be on the outside and the same side of a transversal. Okay? The final one is corresponding angles. They're a pair of angles on the same side of the transversal and the same position of the line. Okay, this one's a little bit more tricky, but not too much. Okay. So for example, 1 and 3. Okay? They correspond to each other because out of the intersections, they're on basically they're in the same fourth of the intersection. So 1 and 3. Okay? 5 and 7. 2 and 4. 6 and 8. So once again, they're a pair of angles. They're going to be on the same side of the transversal. So in other words, I'm going to have 2 top lefts, 2 top rights, 2 bottom lefts, 2 bottom rights. Does that make sense? Okay? Yes, ma'am.
What does the last sentence say?
The last sentence down here. Pair of angles on the same side of the transversal and on the same position of the line. Okay? So in other words, on the line, they're on the same position, yes. On top of the print. Okay? We ready to continue? So looking at example 2 on the next page, it says we're going to use the figure below to classify the angle pair and determine the transversal that forms them. Okay? So this isn't hard. This isn't too difficult. We're just going to look at this one step at a time. Okay? So first of all, angle 1 and angle 5. Okay? First of all, what is the line name that's going through it? Line what? Line C. Okay? I'm looking at this right here and this right here. These are my straight lines that are crossing my two other lines, correct? Now answer me this question, class. Are these two lines parallel or are they skewed?
Parallel.
They are skewed. Because if you look at them, they don't have the same slope. If I continue this on over here and over there, they're going to cross. So they are skewed. Okay? So 1 and 5, looking at the previous page, what kind of angle do I have here? What? That's exactly right. They're corresponding. They're corresponding because when I look at this, I see that I have an angle. They're on the same side of my transversal, and they're basically in the same spot, upper left and upper left. Does that make sense? Okay? We're doing good. How about 4 and 6? What's my transversal? C. And then my type of line? Alternate. Alternate interior angles. Okay? The reason, yes ma'am.
Okay, the one that you just did, angle 4, I don't get which line's angle 4 and which line's angle 6. Oh, wait. Never mind.
Okay, so angle, when I look at it, I'm going to look at which part of where the line has intersected do I have 1, 2, 3, and 4. Those, and it's a very valid question because it's a very important question to know. Okay, so I've got 1, 2, 3, and 4. 1, 2, 3, and 4 are my different angle numbers when I'm looking at it. Okay? So an angle is formed by, number 2 lines. An angle is formed by 2 lines, or 2 rays that come together, and they have a common point. So here I have an angle formed by 2 lines that are intersecting, and they have the common center point. Okay, does that make sense? Very good question. Okay? What about angle 4? Angle 4 and angle 10.
Alternate exterior.
Alternate exterior. Now this one's a little bit interesting. Which one? What is the transversal that's going between both of these? A. Because this line is going between here. So you could have, depending on your perspective of angles, you could have either a horizontal or a vertical transversal. Does that make sense, class?
Yes.
Got it? Okay. Let's look at angle 2 and angle 9.
Same side interior.
Very good. Now, if you want to abbreviate these, like same side interior, you want to do S-S, INT. I mean, if you want to abbreviate it, that's fine as long as you know what you're talking about. And as long as on a test I can see, or a quiz or a test, I can see what you're doing. And by the way, this might be something that you see on a quiz. Coming to a theater near you. Yeah? No? Okay. What is my transversal for 2 and 9? A. Very good. Okay, how about 4 and 12?
Corresponding angles.
And my transversal?
A.
Okay. How about angle 3 and angle 9?
Alternate interior.
Alternate interior, very good.
How do you have this interior or exterior?
Very good question. So if I have interior, it's because it's inside of my lines. Okay, so on my set of lines right here, where I have 3 and 9, they're on the inside of this line and this line, right? Think of it as I've got a sandwich, and my interior is everything that's between the pieces of bread. This is my piece of bread. Here's my filling, and then I'm going to butter my grilled cheese sandwich with the stuff out here, so I can fry it up and get a good grilled cheese sandwich. Okay? Okay, alternate. And what is my transversal class?
A.
Very good. All right. Who can tell me what angles 2 and 7 are?
Alternate exterior. C.
And the transversal is C. That is correct. Very good. All right. Let's take a look at 3 and 12.
Same side interior.
Hold on to
And what's my transversal?
A.
And finally, 1 and 7.
Exterior angles.
What kind of exterior?
Same side.
Same side exterior angles, because look, 1 and 7 here, they're on the same side of my transversal. However, they are exterior. Very good.
C.
And my transversal is
C.
C. Very good. All right, let's take a look at topic 3-2, your next worksheet. Okay, the thing for this one, when it says use figure 1, I don't know why they did this, but they put figure 1 and 2 on the back. Okay? So what I'm going to do is I'm going to get out my handy dandy one, and I'm going to put it up here for us to see. So look at figure 1, it says. Looking at figure 1, we're going to tell whether or not, what the type of angle pair is. If it's congruent, what does congruent mean? Same or equal, same size, very good. And are they supplements? What does it mean if two things are supplements?
They equal 180.
They equal 180. You're just on top of it today, aren't you? Very good. Yes, they equal 180 degrees. Remember how we did in topic, the second part was, yes, the second part of topic 1, where we did the complements and the supplements, and we did all that. Well, now this is going to come into handy here. Okay, so I'm looking at figure 1. Okay, looking at figure 1, and I'm looking at angle. Compare angle 1 to angle 5. So here's angle 1, and I want to know what it is in comparison to angle 5. What have I got?
Corresponding. Corresponding.
Corresponding. That is correct. And the place that the figures are at, they put them on the back side of this page because they didn't have room, and I don't know why they did that, but they did it. So for now, just look up at the board for the figures. But they're on, if you turn your page, they're right behind there.
Can I just get another one of those?
No, because I won't have enough for...
Well, no, I'm gonna put it back. I just want to look at it. I
Well-
have problems.
For now, look up at the
Okay.
screen, because I'll have it up here. Okay? Okay, are these two angles congruent?
Yes.
Yes. Do the two of them together equal 180?
Yes.
No.
Well, when you stick them together, they're a straight line.
Not necessarily. If I were to add this one and this one together, remember, it's a linear pair theorem that says that these two angles, because they're right next to each other, together would equal 180. These two do not, 1 and 5. Okay, let's look at angles 1 and 4. Now this goes back to our previous sections before today, where we had 3 types of angle pairs. I told you to memorize them, and everyone's like, oh, I don't want to memorize these 3. Now they're coming into play. Okay, what type of angles do I have here between 1 and 4?
Adjacent.
Not adjacent. Yes, I heard it. Vertical. Remember, the vertical angle theorem suggests and states that two opposite angles formed by intersecting lines are what?
Congruent.
Congruent. Therefore, are these two congruent? Are these two congruent?
Yes.
But are they supplements?
No.
Okay? How about 1 and 3? This also goes back to our 3 that I mentioned before.
Absalom and phase 2.
They're not adjacent. They're not a vertical pair.
Parallel.
Starts with an L.
Linear.
Linear pair. And are they congruent, yes or no?
Yes.
No,
No.
because they're not the same, but are they supplements?
Yes. I was testing you.
I appreciate that. Okay. Now, I'm looking at angle 1 and angle 8. This one's from today.
Alternate exterior.
Okay, very good. So first I'm going to look at what side of the transversal are they both on. They're on alternate sides of the transversal, and they're exterior angles. Okay? So I'm going to abbreviate it ALT, EXT, that means alternate exterior. Okay? You're going to see that probably abbreviated on worksheets that you get, so it's important you know the abbreviations, and you're allowed to use them as well. Are these two the same?
Yep.
Will they together equal 180?
No.
Very good. And finally, angle 1 and angle 7.
Same side.
Exterior angle.
Very good. Same side, exterior. I'm going to abbreviate same side as S-S, and then exterior is EXT. Are they congruent?
Yeah.
Yes.
Are they congruent?
No.
But are they supplements?
No. Yes. No. Maybe.
Yes, they are. So, remember, same side exterior angles. They're on the same side of the transversal, but they're exterior to the two lines. As a result of this, you're going to have in two parallel lines like this, they're going to be opposite of each other. They're not going to be equal, but together they're going to equal 180 when we have parallel lines. Okay? Now let's take a look at, it says in figure 1, trace angle 3, so here's angle 3, and compare the following. What type of pair do I have from angle 3 to angle 5?
Same side interior.
Are they congruent?
No.
Yes, they're congruent.
How? Oh my gosh.
But are they supplements? No. A good way to look to see if they're
Oh, I was thinking figure
congruent,
two.
let's look at this right here.
I know.
And if you were to flip it on its side, the transversal, and you were to look at it, this plus this equals 180, and this plus this equals 180. So they're the same, but they're not together going to equal 180.
No, I got it. I
Okay.
was just looking at the wrong one.
So then 3 and 6. 3 and 6, they are on what side of the transversal? Same or alternate? Alternate. Are they interior or exterior? Interior. Alternate interior angles. Are they going to be congruent? Yes.
How would that?
So in other words, 5 and 6 together equal 180, and 3 and 4 together equal 180. Okay? And then, finally, are they supplements? No. So now it just wants us to look through which angle pairs were congruent. What type of angle pairs were congruent? Well, I looked at here corresponding were,
Same side interior.
and vertical were, and alternate exterior were, and same,
What was the thing?
okay, same side interior were, and alternate interior were, okay? Those are the different angle types that were congruent.
What is the one after the vertical?
Vertical says alt X, so alternate exterior. Okay? Now let's ask the question, which angle pairs were supplements?
Linear.
I'm going to look back through here. I had linear and same side exterior. And those are the ones that were supplements. They equaled 180. Yes, sir. So now it says, use figure 2 and compare angle 1 to the following. Okay? So, angle 1 and angle 5, they're what?
Corresponding angles.
Okay? Are these two congruent? Are they the same? No. Do they equal 180?
No.
No. What do you notice about these two lines here compared to these two?
They're a lot more
They're
askew.
They're skewed, and were these two parallel?
Yes.
Were these two parallel?
No.
No. So as a result of that, that's going to change a lot of our answers. We'll have the same types of angle pairs, but that's going to change whether or not things are congruent or supplements. Okay? Let's look at 1 and 4.
Vertical angles.
They're vertical. Are these two going to be congruent? Yes. The vertical angle theorem says that two vertical angles, two opposite angles formed by intersecting lines are going to be congruent, but they're not going to be supplements. Okay? What about 1 and 3? They're what kind of pair?
Linear.
Linear. Are these two congruent? But are they supplements? Yes. How often is a linear pair going to be a supplement?
Always.
Very good. Always. Linear pairs will always be a supplement. Why will they always be a supplement? Because that's the definition of the linear pair, is that you have two angles that share one side, but their other sides are going to be a straight line. So they're always going to be 180 degrees. Okay? What about 1 and 8?
Alternate exterior.
Okay? Are these two the same? No. These two, look at how this angle is, and look at how this angle is. Okay? And how about, are they supplements? No. What about 1 and 7?
Same side exterior angles.
And are they congruent?
No.
And how about supplements?
No.
Not in this case, because they're not parallel lines. Okay? So in order for us to have something like that sort of relationship, we're discovering that we have to have a parallel line. The two lines have to be parallel. That becomes very important. Because otherwise you're getting into dangerous waters of having to guess, well, it kind of looks like it, but if they're not parallel, it doesn't help us. Okay? Looking at final two, 3 and 5.
Same side interior angles.
Okay, 3 and 5 are interior. Are these congruent?
No.
No. Do they equal 180? Okay. And what about this up here? 3 and 6.
Alternate interior angles.
Okay, 3 and 6 are alternate
Interior.
interior angles, are they congruent?
No.
Are they supplements?
No.
Okay? So out of these right in here, which ones of these were congruent?
Only the vertical.
Only the vertical. And which ones of these were supplements?
Only the linear.
Okay? So then if you turn the page, conclusion from all this. What did we say? We've already discussed it, but how were the two of them different?
One of them was askew, one of them was parallel.
Okay, figure 1 were parallel, but figure 2 were skewed. Okay? So which angle pairs were always congruent?
The linear.
Okay.
Or I meant, the other one.
Which one were always congruent?
The vertical.
Okay. And which ones were always supplements?
Linear.
Linear what?
Angles.
Linear pair.
Oh yeah.
And how about it, when were the other ones always, when were they actually congruent or supplementary? When we had what?
Parallel.
Very good. When we had parallel. Okay? When we had parallel lines, they actually work together. It's kind of like, think of it like a principle of life. If you don't have two people that are going the same way, at some point they're going to get mad at each other and cross paths. Right? Think of it that way. But if you have two people, let's say in a classroom or an organization, that are going the same direction, have the same idea, have the same thought. So for example, Frederick, you play football. That's right? Play football? I know you do too, but I was just picking on him. Okay, you two, you play football. Okay? What happens, you guys on offense or defense?
Offense.
Both you're on both of them. So let's talk about offense. What happens on offense if I decide if your quarterback calls a play, but someone else decides, no, I'm going to do something different? What's going to happen in your game?
And I'm going to throw the ball. I'm going to throw the ball where it's not supposed to go.
You're the quarterback?
Yeah, I'm going to throw the ball where they're supposed to be, and it's going to get intercepted because they didn't run that route.
Okay, so in other words, they're not going the right route. So tell me this. If you have a player that constantly does that, let's say your tight end or your receiver constantly decides that they're going to go off on a different path. They're not going to go on the same trajectory, same parallel trajectory as you're going to go. What's going to happen later in the locker room?
Get beat up.
You two are going to cross paths. Your lines will be skewed, and there'll be fiery tempers, and people will be angry. But you know,
He's not going to get past the ball.
and he's not going to get past the ball, which will make things even worse. So you see, that would be like a real world example. That's a non-visual example, but it's a principle behind it. Is that when I have two lines that go the same way, you have a lot more chances for things to be in common and for things to supplement each other than you do when they're just going in opposite directions, any which way. See how cool that is? Okay? We have 2 more pages left. Okay? Let's talk through these. Now look on the board. You have 2 homework sheets from this, and I'm going to hand out progress reports. Progress reports are due next period for what?
5 extra points.
5 extra points applied towards what category? Test grades. So you guys will have 5 extra points for test grades. Whoop, whoop.
Did we take a test last time? Do we know what we got?
It'll be on the progress report that you get today. Okay? So let's talk about these. Let's go through these. Angles 1 and 5. What are they? What side of the transversal are they?
Exterior angles.
They're exterior and alternate, so. All right. And are they complements or supplements, or are they congruents or supplements?
Congruent.
Are you going to have something that's both congruent and both supplement? No, that doesn't happen. Okay? How about angles 2 and 3?
Same side and interior angles.
Same side, interior. What are these two?
Congruent.
They're congruent. Actually, no, I take that back. They're supplement.
Oh, I know I will.
They're supplement. They're supplement because, and it makes sense because if you look at it, this angle is the same as this one, and this one is the same as that one. So these two together will equal 180. What? You knew you were right. Very good. Okay. Let's take a look at this. So angle 3, this is pretty cool. Angle 3, it says, is 115 degrees. Ooh, so now we're actually going to put some numbers in this. I know you guys are wondering, when do we get to do math? We love math.
Here's my question.
Yeah.
Even though it's a little bit ahead, it says that angle 1 is 130 degrees. How is angle 1 and angle 3 different? Aren't they supposed to be congruent?
They're just different problems.
So stupid.
Okay.
Just thought-
They're just different problems. Good question, but yes. See where you're going with that. Okay. All right. So angle 3 is 115 degrees. Angle 5. First of all, what type of angle pair are they?
Congruent.
Alternate into.
Alternate interior. So they are congruent. So what does that mean angle 5 is?
115 degrees.
Bada bing, bada boom. As the great Hannibal Smith said, I just love it when a plan comes together. You guys ever watched the A-Team?
Yes.
Mr. T? B.A. Baracus? I pity the fool! Never mind.
Extra small.
All right.
Extra small.
Angle 1, it says, is 130 degrees. What is angle 7?
130 degrees.
130. As my good friend from the Muppets would say, waka waka! Okay. Nobody Muppets fan in here?
I got that one.
Okay. Now this one is going to be a little more tricky.
It is tricky.
Okay, angle 8 is 47.
It gives you the measure of angle 3.
Okay, and it wants to know what the angle, ignore what it said previously the measure of angle 3 was.
They're different problems.
Okay.
It's still frustrating.
Okay, so ignore that. And I'll even get out my handy dandy whiteout.
It's handy dandy on the side.
Okay.
You can't see it.
Okay. So I want you to tell me, first of all, are angle 8 and angle 3 the same?
No.
No. But are they complement? Are they supplements or congruent?
Supplements.
Supplements. So two angles are supplement, then that means what?
Subtract 47 from 180.
Okay, so they add up to equal 180, which means that 47 plus the measure of angle 3 equals 180. So I can subtract 147, or I mean 47, and I get 133 as my answer. Okay? So that's the most complex one we've had to do so far. But the cool thing is, am I going to have something other than 180 there? No, because they're supplements. They're either the same or they're supplements. Dude, that's awesome. Because that makes it easy. I don't have to worry about a 90-degree something. I don't have to worry about two angles being 90. I don't have to worry about two angles being 137.3. They're either going to be 180 or they're going to equal each other. Okay?
Good one.
Okay? So now, ooh, this is fun. Algebra.
Yay!
All right. What type of angle pair do I have here? First of all, what side of are each of these on of the transversal?
Alternate interior angle.
They're alternate and then they're interior because they're on the inside. So alternate interior. So are these two angles
Equal.
or are they equal 180?
They equal.
They're equal.
Yeah.
Okay? So I can set them equal to each other. Okay? So I'm going to subtract 2x from both sides to get my x by itself. I'm going to add 40 to both sides to get x by itself, and I get x equals what? 30. Okay? So now I've taken and I've used my angle property, and I've said, dude, these two angles are equal to each other. Why? Because this is the type of angle pair that we have. All right? Because of that, I've set them equal to each other. Now I'm going to solve for x. I've done this since Algebra 1. I can do it. I put my x's on one side, my numbers on the other. I look to see if I have anything to divide or multiply. I don't. I'm done. X equals 30. Okay?
That was so awesome.
Now, type of angle pair,
Same side exterior.
they're same side exterior. Oh, no, they're not. They're corresponding, thank you.
Oh, sorry.
So, are they the same or are they equal to 180?
They're the same.
They're the same. Because this angle and this angle, these two angles equals 180. These two angles equal 180. So these two together are going to be equal to each other.
X equals 8.
Minus 2x minus 2x. So I get 2x equal minus 30 equals negative 14. I'm going to add 30 to both sides. And I get 2x equals 16 divided by 2.
8.
Divided by 2, x equals 8. And what do we call that in football, gentlemen? Touchdown. And what would Kung Fu Panda call that? Skadoosh.
I forgot all about it. Oh my.
I love that movie.
I never saw it, but I was always told I was like Kung Fu Panda because I was awesome and I was perfectly sized to be Kung Fu Panda. So
But he was agile on his feet.
that's like me.
Can you do the splits to get cookies?
No. I couldn't do the splits to save my life. Okay, now
No one cares, Savannah.
let's take a look at these. We got 3 more problems left. We got 3 more and we're done. Everybody happy? Okay, do we have homework? Yes.
When do we not have homework?
When he's dead.
Yeah,
On test days, we usually don't have homework.
yeah. All right. What type of angles do I have here?
Same side interior.
Same side, interior. Now, are these angles the same or do they equal 180?
They're equal when they-
Ah!
Very good. So I'm going to add them together. And I'm going to set them equal to 180. Okay? So combine like terms. Okay, so I have 5x plus x, that's 6x. Negative 32 and 8 is what? Negative 24 equals 180. Add 24. I get 6x equals 204. Divide by 6. And x equals 34. Touchdown. Okay? All right, now this one is extremely tricky.
Alternate interior angles.
Okay? These right here are alternate interior angles. Are they the same? Do they equal each other?
They equal 180.
They equal 180. Okay? So, I have 4x minus 40 equals 180 plus 40 plus 40. 4x equals 220. Divide everything by 4.
55.
X equals 55, yo. And now for the finale. La presse de résistance. The most exciting problem we're going to do. Oh my.
Okay, so 3x equals 11z.
Alright, so when I look at this problem, I need to find x, y, and z. First, let's take a look at our y. What angle is this one equal to?
2y equals 18.
It's equal to 18 because they're,
Congruent.
okay, very good, they're congruent. So I'm going to draw a little line here. Whenever I indicate angles being congruent, what I do is I draw a little dash through the angle, a little tick mark, if you will, through the angle, and I'm going to put that for 1 for the first set. Then I'm going to put what other two angles are equal.
3x and 11z.
And I'm going to say, hey, you two are equal. Okay? So let's first 2y equals 18, divide by 2.
Y equals 9.
That was pretty easy. Okay?
Yep.
Pretty straightforward, pretty to the point. Now we're going to get into a little bit more tricky of a problem. Okay? And this is going to come back from something from pre-algebra that you may or may not remember. We've discussed it before in here. Okay? What are the sum of the interior angles of a triangle? What?
180.
Very good. Very good. So when I have interior angles, these three equal 180 degrees. So I'm going to plug in my 9 for the y. I'm going to plug in 9 there. Okay? I get 3x plus 18 plus 63 equals 180. Okay? 63 and 18 are 81.
X equals 3.
Okay? 180, subtract 81, subtract 81. 3x equals 99.
Got it.
Divide by 3.
And then if 3x equals 11z,
Okay? So,
by 11.
3 times x, which is what?
Don't just divide 99 by 11.
Okay? 3 times 33 equals 11 times z. 99 equals 11z, divide by 11, divide by 11, z equals what?
No. I'm going to wish.
Okay, any questions? Everyone get that? So in summation, what we did for this problem, we first saw what could we easily get set equal to each other. That's going to give me a quick and easy answer. Okay? It's like fast food for the brain. Okay? I got my fast food done. So now I'm going to move on. What's my more tough one? Well, I can set those all equal to 180. And then finally, I can set them equal to each other. And that, as they say, is that.